the two people who are waving at me. Shh. Hello, everybody. Hello and welcome back to COMP1511. I see that there are fewer of you than there were last time. This corner of the room's gone. Did you scare them off, or? But welcome to those of you who have made it here, and I guess hello to people watching the lecture videos. You're also valid people. So, the mouse is frozen. I'm using a new setup to try and get diagrams and stuff better, and it's new, so what's happened here? Oh no. Chrome. This worked like a minute ago. Okay, well that fixed it. Cool. So, shh. Hello, welcome, all those good things. So, shh. Today's lecture we will be looking at FruitBot, a very exciting bot to bring fruit to all first-year students. And also even more linked lists, because we love linked lists. Shh. So here's the list of things that allegedly you can do after today. You should be able to start on the last assignment, which is FruitBot. So you should be able to go from this lecture, cool, I know how to write the assignment, everything's good. Work with multi-file C programs. So C programs with more than one .c file. Magic. Understand the purpose of .h files. Do more linked lists, free linked lists, more linked lists, all those good things. So, here's our admin stuff. Step 1, don't panic. Step 2, assignment 2 was due yesterday. How many of you haven't started assignment 2? Okay, well, I'm sorry, but sad face, right? Oh, I'll turn those lights down. Lights. That one? Cool. Okay, so yeah, if you haven't started assignment 2, shh. If you haven't started assignment 2, I have some bad news for you. It was due yesterday. But assignment 3 is out now, so you get absolutely no break between assignments because we love to torture students. Because we care a lot about our students. But assignment 3 has come out. This week's student lab helped you get started. So if you do the lab this week, that's like the assignment started. You've written the first part of the assignment, so that's all good. Week 10 weekly test due Thursday. Help sessions are happening. I said last week there were help sessions on certain days and I was wrong, but because I was wrong, we made there be help sessions then. So thank you to the person who posted in the forum being like, what, you put this thing up and said there were help sessions, but there weren't. So we made help sessions happen, but there aren't all of the assignment ones this week. So the normal ones are happening, but not all of the extra bonus ones. Cool. So introducing FruitBot. These emoji were a great use of my time this morning. So we have the assignment spec, which I will attempt to open. Cool. So you'll go through this in your tute. I won't go through it in too much detail. But basically, your task in this assignment is to write a bot that makes the world a better place. So it's going to pilot a drone which ferries fruit to you and UNSW students so they stop eating junk food and have a healthy diet. What a great thing to do. And so, more importantly, your bot must successfully buy, transport, and sell fruit in a simulated world. And you'll be coding this, surprisingly enough, in C. Come on, don't lag out on me. So the world in which your bot operates has things spread out in a ring. You can only go like around the ring in directions. You can't go through the big mountain in the middle. And you can go from place to place. So like CSE is joined to the Bondi banana growers, and so on. I will let you read through the spec in your own time. But sort of the key things, there are 3 things you can do. You can move, you can buy things, or you can sell things. You need to move to a place that will sell things to you if you want to buy things, and if you want to sell things, you've got to go to a place that will buy them from you. That is all outlined here. We give you several files to work with. Here is some example stuff. Okay, cool. It's due on Sunday, the end of week 13, because we can't have anything due later than this. This is like the deadline for deadlines, basically. So we don't submit it late. And So how many of you tried to submit stuff on Sunday night and couldn't log into VLab or the VPN or something? Okay, surprisingly a few of you. I think what happened is we used up all of the VPN in UNSW, like 1511 students. So don't do that again. Okay, 1521 also had an assignment due and probably other courses as well. So you silly, silly people. Don't submit your work at the last minute, otherwise this will happen. That's clearly the moral here. Cool. So, I guess the key things here, similar to intensity, it's a stateless bot. So your bot is called and given, like, here is the current state, please do one move, and then the bot does that move and then ends. The world is randomly generated, so you can't assume there is any particular fruit there. So you can't assume that there will always be Mars bars, because sometimes there won't be Mars bars. And in big shady letters, do not change the structs. You're given structs that represent, like, your bot is a bot struct, and it's in a world which are location structs which are joined together. Don't try and change these. Like, don't try and change your bot's location. Just make the move, like print out move 3 or something. Don't actually move the pointers around. Cool, and so we'll look at the assignments and code, but before we get to that, we have multiple save files. Actually, I'll leave that until a second from now, a moment from now. So let me open VLab. The mouse is really laggy. Cool. Right, Fruitbot. So for the assignment, assignment spec, you're given several files. Somewhere down here, maybe. Cool. So you're given fruitbot.c, which is the starting code for the assignment. You're given fruitbot.h. We'll talk a bit what .h files mean shortly. You're given fruitbot input.c, which will handle all of the input for you. So this one, fruitbot input.c, you don't have to understand this. It's really complicated and all this stuff to try and interpret all of the input for you. So this handles all of the getting the information about the world, and this will just give you a struct. The struct it gives you will be this bot struct here. So you can read through these and see all of the fields in them and so on. The starting code you have is this fruitbot.c, which I have conveniently downloaded already, I hope. Fruitbot.c. Okay, so the first thing you should do is replace your name here with your name. Cool. On insert date here. What's the date today? 15/05. Excellent. So for the assignment, we have a main function like we did in intensity. You don't have to change this. You're given a bot struct that has all the things in it. The first thing you've got to do is print your player name. So cool, I've started the assignment, printed out my player name. And then you have to make a move of some kind. And so the moves you can either make a move wherein you move your bot. You can make a sell move wherein you sell a piece of fruit that you have. Or you can make a buy move wherein you buy fruit. Are you all talking because you're bored or like you don't understand, or are there any questions? Okay. So does this make sense so far? I've sort of skimmed over a lot of things. Conceptually, for this assignment, you're making a bot that will buy and sell fruit. It can go to a place that sells fruit or buys fruit, and it can buy fruit from places that sell fruit and then sell to places that buy fruit. Like, if an apple orchard will sell you apples, you can buy apples from them, and if Matthew's Theatre A will buy apples, you can sell them apples. So the reverse sort of thing. The way that we make these moves, we can do like, that is very laggy. Are you all using up uni-wide? So you can do like move one. We'll move one around the circle. And I will get that diagram. Oh, so close. Cool. So I made a diagram for the chute. I swear I made a diagram. Okay, maybe I didn't. Ah, this is the diagram. So an example world that you might have would be this one here. And so the input that you're given, or the input that the fruitbot input program is given, which it parses and gives you the struct of, it says what your battery capacity is. So every time you move one place around, you use up 1 kilojoule of battery. You can't go over your maximum battery capacity. If you run out of battery entirely, then I'm sorry, you're stuck, you can't move. But you can buy electricity from electricity stores, I guess. There's a maximum number of kilograms of fruit that you can hold at one time, and there's a maximum number of places you can move at one time. And so those do not change. The locations in this world, we have CSE, which is of type other, Matthews A, which will buy a kilogram of apples for $51 a kilogram. Quadrangle is other. Campus charging will sell electricity for $4 per kilojoule and so on. The way that these work, Matthews A will buy no more than 1 kilogram of apples ever. So once it has bought 1 kilogram of apples from the bot, it doesn't want any more apples after that. And similarly, the Kensington Apple Farm will sell 3 kilograms of apples for $18 per kilogram. You can't buy more than those 3. Like you buy 3 and then that's all of the apples gone from there. Yes? Will the places ever reset by themselves? No. So the way that the world works, you have a fixed number of turns in which you're allowed to be in the world. In this case, it might be, it doesn't say 4 or something, but the world goes for a fixed number of turns. You can make that many moves of buy, sell, move around, and then at that point the world ends. And the goal is to have made as much profit as you can. And then your thing will be run again on a different world, and a different world, and a different world, and so on. Cool. So does that make sense so far? Yep. Yeah, so the maximum move field is the maximum number of places you can move at once. So you can say move 3, for example, to move 3 places around. But you can't say move 8 to go 8 places around. You can only say move 7 at the most to go 7. But then you could make a move 7 and then another move 7 afterwards to move another 7, and so on. And so I put together a diagram of this world. And so in the location we had CSC is joined to Matthews A, is joined to Quadrangle, joined to campus charging, and so on. So they're all joined around in a loop. You can move in 2 directions. You can either move west, which is this way, or east, which is this way. So you can go from any place to a place before or after it, or east or west of it. Cool. So does that all conceptually make sense so far? Your goal is to move to some places, buy and sell some things, and at the end of the day, try and have as much money as possible, as much profit as possible. Yes?
So if we start out with $100 and we end up with 70.
So the question was, if we start out with $100 and then we end up with $70 at the end, do we lose marks? You don't really lose marks, but you haven't made a profit. You've done a bad job. Sort of. The goal in terms of like marks and stuff, assignment spec, come on. In terms of getting marks, your bot will be run in a single player world, so with just your bot. And if you do a really good job with that, you can get up to a distinction. And we also have multiplayer worlds, so we'll put your bot and a bunch of other bots in the same world, and then it will also have to make a profit there. So if you often make a non-zero profit, so you often make more than no money, you will get a credit. Cool. This one here. So let's write some bot. Actually, let me see the thing. Cool. So in the lab exercises, you're given a number of different worlds that you can experiment on. So we looked at world 0, which is a very simple one. And so let's get this into our thing. Copy world 0. Damn it. Okay, terminal over here. Can you believe like how hard it is to just move windows around a screen? Surely as computer scientists we could have solved this by now. Okay. So in the lab you're given some commands to copy the various world files. So you can see world0.txt has this stuff from before. It's got the various types of things. And so I can run my bot. You will be given the command to compile it, I think. Do we not give you the command to compile it? There we go. So to compile your code, you're going to be using multiple .c files. So I'll move this to the top. And so I'll go over in a minute what all this stuff actually means. But the thing you need to know for now is that you can have DCC and then multiple something.c to compile all of those files together. So in this case, I'm saying a DCC fruitbot.c fruit_bot_input.c that compiles both of those files together and gives me one program called fruitbot_world. And so if I run my fruitbot_world program, it just sits there expecting input. If I give it input, it'll probably just be like, what are you doing? Oh, prints out my name. But if I give it input from world0.txt, I can see that it's made a move. It's decided to sell 1. I'll drag that a bit bigger. So I've given it this triangle bracket thing here means redirect the input from world 0 into the program. So it's given it this world 0 information. So it's given it all of this stuff in this file. The fruit world input file has done all the processing for us. I've just been given a bot struct. I don't have to do any scanf myself, just get the bot struct. And then I make a move. This is the starting code. It makes a silly choice. It either it moves one, it sells one, or it buys one. Very clever. So does this make sense so far? If I run my fruitbot like this, it makes some decision. In this case, it's selling one thing. Cool. Is that all good thus far? What are the questions that you have about this? This one down here? Yeah, so the question was, is this $117 our starting money? So yes, it is, but it's also the amount of money that you have right now. So this is an important thing to get. You don't know the information about previous turns. You just know the information about right now. So you know that right now at this point you have $117. This could be the first turn, it could be not the first turn. You don't know, but you know that this is how much money you have right now. So in this case, this is the starting money for this world. Cool?
In a multiplayer world, say there was a place that was buying 3 kilograms of apples, and you had 3 kilograms, but then another player also wanted to sell from the same place, and so you could only sell like 1 each, right? What happens with your extra apples? Is there a way to get rid of them without them?
Cool, so there were sort of two questions in there. The first one was, if you're in a multiplayer world and multiple bots try and sell apples to the same person. So if we are at, let's say we're at CLB7. So I'm at CLB7 and you're also at CLB7. And we both try to sell 3 kilograms of apples to that location. Because it will only buy 3 kilograms in total, it'll take 1 kilogram from each of us. The idea being that because it can't split into like half a kilogram of apples, it can give us both 1 kilogram and then there's 1 kilogram left over. So like if it had 6 kilograms of apples, we would both get 3 each. And then the second question was, what do we do with the leftover ones? So if you buy some apples and then you go to sell them, but you can't sell them all because someone else has like sold things and they no longer want as many, you can get rid of things in the campus compost heap. So there will always be a place that will buy anything. So you can sell it, any sort of thing that you have, for some tiny amount of money. Cool? No, so you can't just drop things on the ground. You've got to sell them to a compost heap. Cool. Are there any other questions? Yep. Sorry, can you say that louder? I'm not sure if I understand your question. Was your question like, do you know what all the worlds will be like in advance? Yeah, so the worlds will be randomly generated each time. The world won't change once you're in it. So in this world here, like you will continue being in this one world. Shh. You'll continue being in this one world until that sort of game is over. And then the next world that you're in will be another randomly generated world. So for example, this one only has apples. But if we cat the more complicated one, world 5, we can see world 5 has watermelons, oranges, apples, durian, banana, electricity, and that's it, and oranges. Cool. Okay, does that all make sense so far? Yes?
So say like places like will sell 3 kilos of apples and you buy 2, will it change to 1 kilo for the next round?
Yep, so that's another really good question. If the place will buy 3 kilograms of apples, and then you buy 2 kilograms of apples from it, will it sell 1 kilogram of apples for the next round? Yes, it will. Let me try and use the powers of modern technology. Thanks for your vote of confidence, tutors. Cool, it's totally going to work. I do that thing, and then I do this. The future is nearly here, but not quite. So if I go back to this world here, and I'll just try and also get the descriptions. Cool. So when we start out, Matthews A will buy this button. Is that readable? No. Is that readable? Cool. So Matthews A will buy 1 kilogram quadrangle campus charging will sell 100 kilojoules of electricity. The apple farm will sell 3 kilograms of apples. COP7 will buy. Cool. And so then with these locations, Matthew's able also buy. Say that you are a bot. Cool. And so you're going to start out like here. Cool. So say you're a bot, you're starting out at CSE, and you want to go and buy some apples from the apple farm and sell them to someone to make some money. So in order to get to the apple farm, right, you need to go 1, 2, 3. Move 1, move 2, move 3. So if you set the move 3 command at this point, you would move, move -3, you would move in the backwards direction, 3 locations. And so you would thus end up here. Is this all good so far? So move -3 will get you to the Kensington apple farm. A positive move goes in the east direction, and a negative goes in the west direction. I don't understand. I'm sorry. I think you're trying to make a joke and I don't get it. I'm sorry. So if we're at the Kensington apple farm, it wants to sell 3 kilograms of apples. If we say buy 1, we buy 1 kilogram of apples from it, and so now it only has 2 to sell. So we can then, it says, cool, does that make sense? So because we have bought 1 kilogram of apples, it will now only sell 2 more to anybody else over the course of this game. If I then wanted to sell them at CLB7, I want to move 1, 2 in this way. So I can go move 2 to move 2 in a eastwards direction. And so now I am at CLB7. And if I then said sell 1, I will sell this apple to CLB7, and now they only want to buy 2. Does that make sense? Cool. Do you know how many players will be in a multiplayer game? It'll be a variable amount, but it'll be the same for one world, like it won't change within one world, and you can find out by looking at all the locations. Cool, yep. Say that louder. Will you know where everyone else is? Yes, so will you know where everybody else's bots are? Yes, you will. You can look around the world. Each location will say these are the bots that are currently at that location. Cool. Was there another question there? Yeah? Hang on. Shh. No, the prices do not change over the course of the game. So the only things that will change over the course of the game are the number of things that each place will buy or sell, and then like the number of things you currently have in you, the number of electricity you have. Yes? No, can your bots sell to other bots? No, unfortunately not. That will be too hard to like coordinate. You know, students working together is not a thing that would ever happen. So yep. Hang on. Shh. So what happens if you try and buy, or if you want to buy more than a place sells? If I was at the Kensington apple farm and I said buy 100, and they only have 2 kilograms, I would just get 2 kilograms. So there's no penalty for trying to buy more than you can. You'll just be given the amount that you can. Cool. Was there another question? Do all the bots start at the same place? I'm not sure. I think so. Tutor is nodding. Cool. Cool. Good question. Does everybody move at the same time, or is it in turns? Everybody moves simultaneously. So you'll all be asked to, you know, make one move, and then if they'll all be done at the same time. Cool. Any other questions? Yeah, so if two people are in the same place trying to simultaneously buy something, they will get like the amount they each asked for sort of spread evenly. If that makes sense. So if we both try to buy 3 and they only have 2, we'll get 1 each. Was it? I was hoping no one would ask that. I think it's still 1 each. I have to check. Cool, one more question? Yep. Cool, good question. So it says the maximum moves is 7. What that means is that the maximum distance that you can move in 1 turn is 7. So for example, if you tried to say move 8, because 8 is more than 7, you would only move 7. So that only applies to when you're moving in 1 direction. Cool, okay, one very last question. No, that's fixed in the beginning. That button. Cool, so here's one example place. So this is an example of like a starting world. This is saying that your battery capacity is 105, this isn't going to change. The maximum amount of fruit you can hold is 32, that's not going to change. The maximum move is 6, that's not going to change, those are all fixed. This is not going to change. The price won't change. The amount that they have to sell will change as people buy from them. So that will change, the amount that they have to buy or sell. The locations will change. So your location will change as you move around. So if you move somewhere else, you are now somewhere else. But the properties of the world, like how much something costs, isn't going to change. Cool. So if we go back to some code, that one. Cool. So I'm looking then again at this code. If I'm saying something like move 1, can I do side by side? Oh yeah, look at that. So in my world over here, if I'm currently at CSE and I say move 1, I'm going to move to Matthews A. If I'm at CSE and I said move -1, I'm going to move to CLB7. And so looking at my bot here, if I make it be an even stupider bot, literally just printf move 1. Cool. And so this is my bot if I now compile it. I need to give it some input. Cool. So when I give it the input, it's always just going to move 1. Very exciting. But if I run it in the referee, because of course we have a fruitbot referee, yeah, I did it right. So we can see it's going around the world. It's saying always move 1, so it's moving 1 in the east direction each time. And you can see it's just going around the locations. So we started out at CSE, we moved 1, we were then at the campus compost heap. We moved 1, we were then at the quadrangle. Can I get this back up? Yeah. Cool, so we were at CSE, we moved 1. This is not the same as the picture, okay. We moved 1, we were at the campus compost heap, and so on and so on and so on. You can see we moved to Matthews A and then back to CSE. And then when we went to CSE, we again went to the campus compost heap. So the world was sort of joined. At the very end, I am at Matthews A, surprisingly enough, with the same amount of money as I started with, battery level 50, and -$0 profit because I didn't buy or sell anything. Cool. I might leave the details of the structs. You'll be looking at those in Shoots. Something worth noticing is that in the lab, the third lab exercise, I think. Yeah, the exercise number 3, where can I charge? This will make a bot, and so when you have finished this exercise, you will have a bot that can do sort of vaguely sensible moves. Cool, and then there's a challenge exercise not about the assignment. So let's then look at this aside that I was going to talk about before. So up until now, we've only had one .c file per program. So like our program is hello.c, and we have dcc-o hello, hello.c, bam, that's it, our code works. But we can actually have multiple .c files. Cool, very exciting. In order to call a function, you need to know the information about it. You need to know what it's called, you need to know what it returns, you need to know the input parameters. This is like function prototypes, right? Whenever I forget to make a function prototype, the compiler goes, "No, what are you doing? I don't know how to call this function because you've given me the name, but like, how do I know that you're using the right type? How do I know that you've got the right return value and the right number of parameters?" and so on. And so this is what we'd refer to as an API, which application programming interface tutors. API, application. Cool. Application programming interface is what we describe it as. It's basically the rules for how to interact with something. And so if we look at some example programs, this is totally easy stuff we've done before. We have a function void hello that will just print out hello. We have a function int square that returns some number times itself. So if my main function is hello and then printf%d square 5, it should print out hello and then print out 25. Right, so this is just a straightforward program like we've seen before. And if I have another file called second.c, I don't actually have the code for these functions, I just try and call them. You can't do that, right? Like you can't call functions that aren't there that you don't know about. So if I try and compile this, it'll give me some error about like not knowing what hello is, not knowing about square and so on. And so I couldn't run it. You didn't see that. That's spoilers for the next bit. I didn't think through the logistics of trying to copy this from several different pages. Code. Second. Cool, and I've forgotten my hash includes. Cool, so the first.c hopefully looks like a nice normal program. Is that font size okay? Is the font size too small? Yeah, a couple of people said, I think I made it a lot smaller to test something out myself, so I'll make it a bit bigger. 14, much nicer number. Cool, is that good now? Is it still too small, anyone? Excellent. So, normal program, nothing different fancy here. This is just an example of a normal program. To show first.c. Cool, it compiles, I run it, it prints out hello 25, as we expected, excellent. If I try and compile second.c, like just as is, hopefully you are not surprised that this doesn't work, because I'm trying to call functions that don't exist. Like this file doesn't know about those. Second.c. Cool, we've got all of this big spam. Did you forget a function prototype? Yes, I did, but then you also forgot to write the function. Thanks. I don't think that's the button. Oh, that is the button I wanted to push, excellent. Cool, and so we can't do this because we don't have the functions, right? The functions don't exist in this file. We can combine the two files together. So we can say second.c and first.c. And so now we're saying the functions in first.c should also be in this program, right? And so if we do this, it still won't work. Thanks. But I can do this sneaky thing. I can copy these function prototypes and put them in second. Hopefully. And so hopefully this will now mean, oh, I've got too many main functions. There is a rule that you cannot have more than one main function because otherwise where does your code go to start? So I'll just get rid of the main function in that. But now I can compile it just fine. I didn't return a value. Whatever. Cool. No errors, everything perfect. So what I've done here, I've got my second.c file. This has these function prototypes, and it calls the functions, but it doesn't have the code for the functions in this file here. But because I compile it with first.c, which does have the code for the functions, because the code for these functions is inside first.c, and I compile them together, so I have both of the C file names when I compile it, it will work. And so it'll do the same thing. I can call the functions that are inside first.c from second.c if I give it the function prototypes, if it knows about the functions. Does this make sense so far? Why don't I have to do the prototype but not main? Because I don't use the function. If you want to use a function, you have to know about the function, but because I'm not using it, it's just wasted code doing nothing. Cool. Good question. And so if I wanted to make another thing called third.c, no, go away. Save as third.c because I'm so good at variable names. So I could also compile, like I can make another program, third.c. I can call the functions again from third.c. I have to have the function prototypes again in third.c. So I have to have the function prototypes everywhere that I want to use them, and that's really annoying, right? Shh, that's really annoying, right? If only there was a better way than that. Oh, why can't I alt-tab now? Cool. And so the way we do this is we make what's called a .h file or a header file. And the idea is that we put the function prototypes in this .h file, and then we just include that .h file in the programs that we write. So let's copy this. VLab. Cool, so now if I have myself first.h, I'll talk about this stuff at the top in a second, but I have first.h, I put the function prototypes inside first.h. I can then get rid of them here. I just need to hash include first.h. I have speech marks, not the triangle brackets, because it's a thing that I've made, not like a library function. I can then also do this in second.c, hash include first.h. And so now I've gotten rid of the function prototypes with the inside the .h file, so they're effectively now inside this file as well. And everything should work as before. Cool. So I have my program second.c compiled with first.c. Second.c has the main function, so this is what's going to happen. The function prototypes are in first.h, and the function implementation, the function code itself, is in first.c. Cool? All good so far? Cool. And so back to this thing here. I've got this hash if in def first underscore h, hash define first underscore h, and if. This thing here basically just means we'd call this a header guard to guard the header so that we can't, if we hash include it twice, we're not going to have any problems happening. In this case, because it's just function prototypes, it's fine to hash include it twice, but if we had anything more complicated in here, it gets very sad. And so this is basically just saying if you haven't yet seen first.h, then hash define first.h, so now it's set in the hash defines. Have this stuff here, and then end if. That was not meant to happen. So this effectively means this will only be hash included once. Like the code from this .h file will only end up once in the program itself. Cool. Is that all good? Are there any questions? Yes. Ah, good question. Very good question. I didn't talk about that. Do you not have to include the .h in the command line? No, you only need to have the .c files when you're compiling in the command line. If I also add first.h, it'll hopefully complain. Okay. Well, you get some sort of error message that I would have expected to be a different error message. But you don't put the .h file inside the compiling line, you just have the .c file names, and then you have to hash include the .h file inside the .c files. Cool. All good? Yes? Very good question. Does that mean the .h file has to be in the same folder as the other .c files? Yes. I'm going to call this thing. Just was really clear that they're all in this one folder, first.c, first.h, second.c. And then I do my DCC command without the extra .h, and everything's good. Cool. Any last questions? Okay, let's take a break. Let's take a 10-minute break, as always. Get up, jump around, stretch your legs. Don't just sit the whole time because your brains will get tired. Okay, that's probably enough beeping. Hello again, everybody. How many people just sat down the whole time and constantly ignore my, you're lost. You're lost. Your brain will just fall asleep. You'll be sad. Cool. Shh. So let's have a look at, not enough places. I'll put that over there. Let's have a look at some linked list stuff. Yay! Okay, so first of all, is the volume good enough? Can you all hear me? Cool, that's good. Probably should have asked at the start. Oh, it works now. So I have written review here. I have all of the linked list stuff from previous weeks. I'll just go through it really quickly. So linked lists are a series of nodes joined together. Nodes are a node struct. They have fields in them. We can make new nodes with malloc. We can free nodes. We have to free things because if we malloc it, we've got to free it. We have a reference to a node or a pointer to a node is different to the actual node itself. One of them, this is what malloc gives us. This is what we have when we make a pointer. We can go through everything in an array with like a while loop, while I is less than size, I++. We can go through everything in a linked list with while current is not null, current equals current arrow next. And our standard loop for a linked list looks like, struct node star current equals list or whatever the start of our list is. While current is not null, do something, current equals current next. So for example, to calculate the length of a list, we could do this, have our counter for the number of nodes, increment that each time we see a node, and then at the end, that's our length. Cool. Is that all good so far? Everybody is vaguely happy about linked lists? How many people are vaguely happy about linked lists, just out of curiosity? So it's only people sort of in this section here and there. So clearly, if you moved over here, you'd be, no. I still love you people on that side, even though I'm not facing and shouting directly at you. So I want to look at some more list stuff. We've done iterations through the full list. So iteration, I mean things like printing the list, counting the number of nodes, and so on. I want to look at slightly more interesting stuff, so not just count the number of nodes, but does the list have something with 5 in it, for example, or whatever. And we also need to look at freeing a list, because we have to free our list when we're done, because otherwise we are bad people. Of course, Newton's third law of memory allocation, for every malloc there is an equal and opposite free. So if we make a node with malloc, we must free it at the end. Cool, so let's start out with trying to alt-tab. Excellent. And by the way, the code is up in the usual place. If you go to any of the week, whatever lecture code links of mine, go to like the parent directory link, it'll get you to all of the weeks, and then that'll take you to the current week. I'm not sure if the thing has been added, but you can see all of, what are you doing? All of these files that I've written so far are up there. Are the lecture notes up? Can you see anything under that week? Because if not, then maybe it's all still set to private. Let me have a look. The problem is that there's so many different steps involved with getting this stuff working. So we have a week 11 section, but it's still set to tutor because week 11 hasn't been edited to be set to public. Okay, tutor fixed it before I could. Could you add a lecture code link as well? Yep. Yes, tutors are great. That was not the right button. Cool, and now it's public, so you can now go to it and see. Yeah, no, I'm sorry about that sort of thing. There's so many steps involved. Like, I normally add my stuff, and then Andrew Taylor will add his stuff and make it be public for all of the week, whatever stuff. So I should check that if he hasn't done that, add it to be public. Cool. What did you say? No, tomorrow. Have we done insert tomorrow's topic here yet in lectures? No, we're doing it tomorrow. You'll find out what it is tomorrow. Where was I? Right, coding. So you can go to any of the week whatever lecture code things. Click on the parent directory thing, takes you to all of the weeks. Go to week 11, Tuesday, live code. Hopefully not solution. Cool, not solution. Come on. Cool, so I'm going to grab the list code from last time, if I can. Let's go with this one. Okay. Cool. So this is all of our code from last time. Shh. What I might do is I might make myself a .h file that has the struct in it. If I go to the right place. Code. Cool. So what are the two things I had to have in my .h file? There was the thing around the outside that was weird, and then the stuff in the middle that was useful. So what's the thing around the outside that I need called? The thing that I had that was like this. Do you remember what this was called? You're nodding. What's it called? I'm going to pretend somebody said a header guard. Yes, it is called a header guard. Good work. The convention we have here is we have the name of the .h file with an underscore rather than a dot. So if I haven't got hash define list.h, define list.h, and then ndif down here. And then in here I put my interesting things. So let's put that one there. Cool. You know what, let's put all of this stuff in here. So let's put this one in here so that I have a new node function. Cool. So I will hash include list.h. And so I've got my list.h, my list struct is in here, or my node struct. I've got my new node function. No, do not do that. And so that means that in here, because I've hash included list.h, I can use the new node function and I can use the list struct that I've made. Is it called new node? It is called new node. Cool, so I have my list stuff.c file, I hash include list.h. List.h has the prototype for this, for new node. What do I need to do to compile it so that it works? If I just go list stuff.c, I don't put the .o there. List stuff.c, that could have gone very badly for me. Cool, undefined reference to new node. What have I done wrong? I've got my .h file, it's got the prototypes. I've compiled this file, but what do I have to do as well? Yeah, I need to give it the other file as well. I've got the prototypes in list.h, but the actual implementation itself, the actual code is in list.c. And so I have to also give it list.c when I compile. And list.c also needs to hash include, oops, quotes, list.h. I got a whole bunch of things here spewing incomplete definition of type struct node, and I know that that means it doesn't know what a struct node is. And that's because I moved it to the .h file, so I've got to also hash include list.h in here. This time, oh, and I've got too many main functions. Cool. And so now if I run my list stuff function program, nothing interesting will happen because I don't have any code to print things out. Come on. Cool. So does this make sense so far? I have a nice, clean, fresh-looking function here, list stuff. I can call the new node function because it's in another .c file, and the .h file tells me like how to get to it. Tells me that it exists, that sort of thing. Cool, so I'll make myself a list. Struct node star node equals new node. Node arrow next equals new node 10. So what is this going to look like? What is the list that I've constructed going to look like? 100. Hopefully you're looking at this and you're not going, oh, I'm confused. Hopefully you're looking at this and you're going, oh yeah, it's going to have a list that goes 5, then 10, then 20, then 100. Each time I'm setting the next field of the node to have the new memory that I'm making, and then that node's next field to have the new memory, and so on. And so now if I print my list, oh, it's literally just, oh, what are you doing? Come on. That is not backspace on this computer. Cool, so if I say print list and I give it my list, which is called node because it's the first node, what is going to go wrong here? Implicit declaration of blah, blah, blah is invalid. And so this means I've forgotten my prototype, right? But what if I haven't forgotten my prototype, I just haven't put it in a place that this one recognizes, right? So I can put this into list.h. Come on. And so now because the prototype is in list.h, list stuff.c knows about the function, and thus, hopefully, cool, compiles. So if I run my list stuff, we can see it's printed out 5, 10, 20, 100, null. Is this all good so far? The sort of interesting thing I've done here is I've separated out my struct and some of my function prototypes into a list.h file. And so any of my programs can have the things, can access those functions as long as I compile both of the C programs together. Cool. And so let me get a standard list loop from here. Is the internet really laggy for you guys? Did you just make it slow? It's pretty good. It's pretty bad. Okay, cool. That's close enough. Shh. I have genuinely forgotten what I was about to do. Do you remember? I was going to copy the thing, right? Cool. Open. List.c. Excellent. Cool. So I was going to get myself a nice looking list loop. Here's a good one. Shh. So remember I said all of the... Shh. It worked that time. Remember I said all of the sort of loops you'll do through your list will look very, very similar to each other. You have your condition while current is not null. You do something, then you go current is current next. So in this case, I want to write a program that would tell me whether a list contains a certain value. Just as an example of something that's a slightly more interesting list loop. And then afterwards, if we have time, we will free the list like the good people we are. Cool. So I don't want to print out the list, so I'm going to get rid of this line and this line here. But I want to, not quite like that, I want to see if this certain node is in the list. So how do I check that? If it will unlag. How do I find out if I have a certain node, a certain value inside a node in my list? Yep, check the first one, check the next one, check the next one, and so on. That sounds pretty legit. Yes, it loaded. We live in the future, almost. Cool, and so if I do this, will everything explode? Whatever, that'll do. So I have my list here, right? I have, I made my list before. 5 goes to 10, goes to 20, goes to 100. And that goes to null. Circle, 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 null. So when I have my loop, cool, you can see them both. When I have my, in my list contain function down here where my cursor is blinking, I want to have my list, pointer here is called list. And I want to go through and see if I have a certain value in my list anywhere. So say I want to check if I have the value 10 in this list. So the first thing I do is struct node star current equals list. And so this means make myself a struct node star, a node pointer, a pointer to a struct node, an address of a struct node, whatever you want to call it, called current, and make it point to the same place as list does. While current is not null, somehow see if it has the value inside, and then go current equals current arrow next. And so that current is current arrow next line means that current will now point to here, and here, and here, and so on. Cool. So if I'm looking at this node 5, I want to see whether this contains 10. How do I access the field, the number 5 from inside my node? Yes, someone said something arrow dot, close enough. Oh, you said current arrow data. Cool, very good, I just didn't listen right. So current arrow data will get me this 5 from this node here. And if I want to see if this matches my value, how do I see if it matches my value? I want to use an if statement, right? I'm comparing something, just like normal things. So if current arrow data is equal to value, then I want to say like, yes, we found it. Good question. So with the arrow syntax, is there meant to be spaces? Do you mean like this? Should we have spaces around the arrow? No, you really shouldn't. I don't know if this is in the style guide as a rule. If it's not, it probably should be. The idea with white space is that we want to make things that are different be really clearly different, right? So I'd say something like, when you have a function, you don't want to say like int a, they've got spaces, it's a bad example. Printf, %d, a plus b plus 10 times 50 divided by 60 plus, right? You don't want to have no spaces here because you can't see the different things that are happening. So in this sort of space, you should have spaces around your plus signs and around your timeses and around everything. If it makes sense to not have a space somewhere because they're part of the same thing, like 50 divided by 20 maybe, then have no space. But in general, have spaces between each of the operators. Whereas we don't do that here because current arrow data is one thing. It's meant to be together. So to illustrate that it's meant to be together, we have no spaces around it like this. Cool. That's a good question, and I wanted to say that at some point, so thank you for asking. Cool. So I'm going to say then, well, current is not null. If current data is value found is true, so I found the thing, yay, everything is good. And then current is current next. I'm going to need to have a found. The way that I like to do this sort of thing, I like to start out by saying it's false. And then if I do find it, make it true. And then at the end, return whether it was true or false. This is sort of like a thing if you have, is it daylight savings time? You could have like your, int is daylight savings and not initialize it and then just go through and set it to true or false. But you can also put it to false for a start and then only set the true cases, if that made any sense. Cool, so what is going to go wrong when I compile this? 2 problems, only one of which I'd thought about. Good work. List stuff.c, list.c. 3 problems. One of which is that you can't do lines like that in the middle of your program. Cool. Use of undeclared identifier false and true. So I'm going to need to hash define true and false, right? You can hash define this. You can hash define 1 and 0. You can't hash define values that aren't like 1 or 0. You can't hash define false to be -1 because that's not valid. False is like 0 by definition. If you want to be cool, you could hash define true as like 1 is equal to 1, because if this is true, which it is, then it will be evaluate to true. But you can just use 1 and 0. Much nicer. But I'm going to put these hash defines in my .h file because then it will be easier. I won't have to hash define them in all of my things that I use. I can just hash define them once. Cool. So I put my hash defines in my list.h file. And now I only have one bug left. Control reaches end of non-void function, aka you don't return a value. So what do I want to return from my function? Return null? Found. Oh, you said found, I just can't listen. Cool. Return found. And so looking at this sort of from the top, can I get my diagrams back? Excellent. So current starts out at list, and found is equal to false. While current is not null, current is currently pointing to the 5. If current data is equal to value, current data is 5, so it's not, so it doesn't do the if statement. Current equals current arrow next. Same looking for 10. I go through again. If current arrow data is value, 10 is 10. So I go into the if statement, found is equal to true. Current is current next. I'll continue going through the rest of the list. I need to draw that and I'll just move my arms. I could just quit there if I wanted. I could make my condition be while current is not null and not found. If I have this here, then it will just stop when it gets to the thing that it's looking for. I could also just not have that there and it would keep looking through the rest of the list. So let's do If list contains node 10, printf we found 10. I did hear a question. I was just going to think about it when I had typed that. Doesn't only work for what?
No, does it work for you? Will it only work
I think this is the question you're asking, and if it's not, then tell me what the question you're asking actually is. So you're asking, can I do like not found, like this? So the answer is yes. You can say exclamation mark some variable, and then if that is true, you're saying if it's not true, right? So if I'm saying that if my condition is while not found, as long as found is false, it will keep going, and then when found is true, it will stop. And then similarly in here, in an if statement, you don't need to sort of say if this is equal, like equals true. Implicitly, there's a built-in like equals true. So I can just say if list contains, and then if this is true, it'll do it, and if it's false, it won't do it. Was that your question? Sort of? TCC list stuff, implicit declaration because I forgot a prototype because prototypes are hard. Cool. And so I've run my program .list, it's printed out the list from before, and it's if list contains node 10 returns true, which it did return true, we found 10. Cool, so does this make sense so far? I've written a loop, it looks just like the normal list loops that we see over and over again. It loops through the list, it looks through all of the things in the list. If it finds the thing it's looking for, then it sets this found value to true, and then it returns yes I have or no I haven't. Cool? Cool. What about, let's have a slightly different function. So let's make a function that instead of returning like yes or no, will actually return the thing that we've found. Sure, so what I want to do here is I want to, instead of returning like yes or no, return the actual node that contains that value. So how would I change this? I'm going to keep all this here, but if I actually want to return my value, I'm going to have to have another pointer here, which I'll call found. I'll set that to be null, and then as I go through my thing, I can't have the same name. As I go through my thing, if I find the node, I'll set found to be true, and then also say the node that I found is equal to current. Cool, and so this relatively small two-line change to my code is effectively saying, now I've got a found node pointer. And so when current is pointing to the node that I found, I go, cool, this is the 10 I'm looking for. I'm going to also make found node point to this. So found node will store the memory address of this node 10. And then at the end, instead of returning like true or false for found or not found, I'm going to return the node that I have found, that is the 10. Cool. Is this all good so far? Find node. Cool. And so I'm going to have struct node start 10 will hold this node that I find. I'll say this equals find node 10. So it'll find a node with 10 in it if one exists. And then let's say, what do I have from before? Do I have anything to insert a node after a given node? Not yet, so I'll write some code for that. Cool, so let's say I want to find this node, and then I want to do something like insert a node after it. So let's say I want to find this node 10 and then have another function that will take in this node and put a node after it. So for example, here that would mean something like I found the 10. And then I want to add a new node, say 5 or whatever after it. So I want to have a function that will take in this 10 that I found. And then add this 5 between the two nodes. Cool, hopefully that is conceptually good what I'm trying to do. So call this insert after. In value. Cool, and so let's say this makes a new node with value, and inserts it after node in the list. Cool, so do you remember the steps that we had from last time to, where did we do it here? We did it down here. I'll copy this over here. So the steps that we had last time to insert something kind of in the middle of a list. So here's my list and add this thing in the middle of it. So if you remember here, we decided these were the steps. So if we wanted to insert between the 1 and the 2, insert a new node here, 5, we had to make the new node. We had to make its next, this needs a picture. We had to make its next field point to the one after it. So like, here is my node 5 that I've made. I need to make 5's next field point to the 20, and then 10's next field point to the 5. Cool. So if in my thing here I have the node, this 10 that I found, how do I access the one after it? Like if I need to set the new node's next to be this 20 here, and all I have is this 10, how do I get to the 20? Get rid of the word store and just say, so I can get to it from the one after it, right? So if node is this 10 and the list is like 10, 20, 30, whatever, node arrow next is going to be the 20. So 10 is my node. Node arrow next is going to give me this node with the 20 in it. So I want to make a new node, 5, call it new, with this value that I've given it here, value. I want to make the node news next point to the one after it. So I want to make this step that I had here, make my new one here point to this 20, so the place that it should be going in between. So I've called this one new arrow next equals node arrow next. So that's getting this next field here that I had for this 10, right? 10 arrow next is this 20 node here. So I'm saying my new node 5 arrow next equals the node 10 arrow next, gets me to point to the same place. And then I need to make the node that I'm inserting after. So node point to new node. So that syntax would be node arrow next equals new. Cool. Does this sort of make sense? It's going to be void because I'm inserting it into the list. I don't actually have to give the list back or anything like that. So the idea is that if I have my list and it's this one I had before, 5, 10, 20, and so on, and I want to insert something after the 10, I'm going to make a new node that's a 5, make the 5 point to the 20, and then make the 10 point to the 5. And so that's the step there. And step 1, make a new node, is make the 5 node, make news next point to the 1 after node, so make 5 next point to the 20, and the 10 point to the 5. Excellent. Do you believe me that this will work? Yes. I like your vote of confidence. Perhaps you should not believe me. So this thing here, I've got this find node will give me a pointer to that node 10. And then I can call my insert after function. If I can type. Give it the node to insert after, which is this one I've called 10. And give it the value 5, which I said to insert. And so this is going to print out the list. So make the list the 5, 10, 20, 100, like the hard-coded thing I have here. Print it out. If it contains 10, print out we found 10, which it does. Make a pointer to this node that's the 10 that we find. So make a pointer to this one here that we get from the find node function. And then give that pointer to the insert after function, which will then insert after that node a 5. Cool. Am I missing prototypes? I probably am. Let's have a look. Yes, I am. Thank you. You saved me compile error. And find node. Ah, yes. Cool, let's try that now. Oh, no compile errors. Glad I didn't forget my prototypes. Cool, and so I've run /list here. So my list was originally 5, 10, 20, 100, X. I've then printed out we found 10, because that's what our thing here printed out. I've then inserted this new node 5 after this node 10. And so, you can see in my list, I now have this, between my 10 and 20, I now have a node with 5 in it. Cool. Is that all good so far? Cool. Do you want to try freeing a list in 6 minutes, or do you want to not try shoving something hard into 6 minutes and getting stressed? Try and get stressed, okay. Like rule number 1 of lecturing is don't try and fit something in if you don't have enough time, because it's bad for everybody. So, get rid of the talk slowly sign. It's what the talk slowly sign's for, is so I don't talk too fast. So if we first of all think about it conceptually, right? Full screen. If I have a list, 1, 2, 3, 4, null. Each of these nodes is memory that I've mallocked, right? So in order to free my list, I need to free each of these nodes. Let's say I have a pointer to this one called list. If I say free list, what is this going to do? That's not answering my question. What is this going to do? This is going to free the 1. So now I don't have this node here, 1. But what has happened to the rest of the list? Like the 2, 3, 4, and so on, have those been freed? No, they haven't. Can I still get to them? No, I can't, because I have this pointer list which points to the first node, but since I don't have that anymore, like, what am I going to do, right? So what I need to do instead is have a second pointer. So list points to the 1, and let's say temp, for lack of a better word. So if I make my temp pointer, I'll make my list pointer. I'll put this one on this side. If I make my temp pointer point to 1, this node 1, if I make my list pointer then point to the next node, I can then say free temp. And so then that will free this node here. And then how do I free the next node? I can still get to the 2, right? So I can still free it, so that's fine. So I then make my list point to the 3, so I don't lose track of the 3. Make temp point to the 2. Free temp frees this one, and so on and so on. So does that make sense conceptually? I need to keep track of the current, I need to keep track of both the one that I'm at and the one after it, so that I can get to the one after it once I freed the one that I'm at. 3 minutes, let's go. Free list. Cool, so I want my standard list, struct node star current list while current does not equal null. Do something, and then current equals current arrow next. So what is the something that I want to do in here? I said I wanted to make a temp pointer, struct node star temp equals list. Sorry, equals current. I then wanted to move current to the next one along, and then free this one that I'm keeping track of here with temp. Cool. Look at those simple lines of code that I've written. Do you think this is going to work? Is this going to do what I want it to, what I said it would do over here? I have my current pointer, which points to the thing in the list that I'm up to. I move that along to the next one. I make my temporary pointer stay at the one I'm at, free that one, and then I move along and along and along and so on. Shall we give it a shot? Let's not forget the prototype this time. Cool, free list. Oh, node NODE. Cool, clear, DCC, 2 minutes, we can do it. Free is inside stdlib. It compiles. It runs. We can't see anything's happened because we don't know what's happened. If I compile with leak check and I run it, I do not get an error message saying I didn't free anything, which doesn't prove that it works because how do we know it's worked? Come on, computer, you can do it. So I've compiled with leak check with DCC and I run it. It doesn't give me an error, but I didn't get an error before, so I'll unfree it. Compile with DCC again, run my list thing. Cool, and DCC has said, so when I didn't have my free list function, I got an error saying I hadn't freed the memory that I made. And when I did have my free list function, I didn't get an error, so I had successfully freed the memory. Awesome, we did that in 2 minutes. If you've got any questions, feel free to come and talk to me. Otherwise, good luck with your tutes and labs this week. Start the assignment 3, please. Please don't start it like at the last minute, it'll be bad. Yeah, see you tomorrow.